Okay, let's see. I'm Don. I'm one of the co-founders of Eksigent. I would read the title, but it would take too much of my 5 minutes. So let's move ahead. So we're basically a microfluidics company specializing in tools for life sciences. I'm going to tell you about what we do with micro, nano, and now chip-based analytical tools. Basically 3 platforms. Nano, we're in proteomics applications for LC-MS. Our Express LC product line goes towards small molecules, but running now in the microflow format. And then, as I said, we'll have microfabricated systems that are really, I'm going to talk about our proteomics version of that today. To go quickly through, we've been doing this for a while. We came out with the first commercially successful direct pump system into proteomics space, and we've been pushing the limits on that ever since. I'm going to tell you a bit about the two latest entries into the space, the Nano LC Ultra and what we're calling the Chip LC Nano Flex. Don't have to do that. All right, so Dave talked about this a bit last year when he did the 5-minute thing. Essentially, we did our first major upgrade on the Nano LC, putting in high pressures up to 10,000 psi, new auto sampler, temperature column control to get better precision out of the system at running with much higher pressure so you can get long columns or small particles. The other thing that we did, which was nice about the system, was changing it so now within one package you can have anywhere between 2 and 5 pumps, so you can run a single gradient all the way up to dual gradients plus a fast loading pump. What really matters is the performance you get out of the system, and this is kind of shown here where you've got repeated runs at very high pressures. The real benchmark here is the precision we get out of the system on a very routine, robust basis. We're getting RSD's retention time typically better than 0.3%, running at anywhere tens of nanoliters to hundreds of nanoliters in this case. So you're really looking for improved peptide AD, quantitation, and scheduled MRM is really one thing that we're shooting at. So now we've done a lot of great work. We've got the pumps here doing really well. We heard from Ian Jardine and Tom about the past and where mass spec is going, and they've made huge strides in that case. And if you look at what's kind of going on in the middle here, still, even though Gary's done lots of work with the interface, you've still got these hair-like capillary columns that Rod Hendrickson talked about this morning that are, my mind is more like spaghetti when you tie them all together with the fittings and so forth. And if you play with spaghetti enough, you really end up getting a little frustrated in the lab. It's kind of a mess. And so what we've been doing is trying to put together our expertise in microfabrication to get a tool to solve a bit of this problem. And that comes in the form of the Chip LC NanoFlex. The real goal thing to take away from this is we're trying to provide ease of use, workflow flexibility, and improve precision in the workflow. Okay. How do we go about it? The Chip LC has 3 slots. Basically, you can take and put in 3 different chips. Chips basically come in a little cartridge that's about this size. Okay, so you have traps, columns, what have you. Depending upon the 3 chips that you put inside the box, you can carry out different workflows. So you can do a direct inject, trap and elute, or you can use dual column switching to get higher throughput in the experiments. We've come up with a unique connection system. We actually bring in the fluid from the edge of the chip, so we can get in there sub-nanoliter dead volumes that basically are good to thousands of psi. Because we're microfabricating these things, they're the same time after time after time after time. So what we end up getting now is column-to-column reproducibility that we spec at better than 2%, typically a good deal better than that. Okay, the slots actually have temperature control in there, so you can avoid the problems of laboratory temperature variation that we heard about this morning from Sue Abatiello. So those things are all taken care of. If you look at some of the data you get out, this is a BSA Digest standard that was done with the Nano LC Ultra plus a Nano Flex. You can see the specs there. This is actually more impressive data. It was done. This is data from Christy Hunter over at ABI. In this case, she was running a dual column experiment and then switching back and forth between the two while running it into the nice mass spec with a lot of, you can see all the different colors showing all the different MRMs that she was taking. And in this particular case, as she switched back and forth, you can see that while the one column was equilibrating, the other column was shooting into the mass spec, generating another set of data. So you're basically getting better duty cycle out of your really expensive mass spec there. On the Express product line, it's been around for a couple of years now. We did from 2004, where it was the fastest gradient HPLC at the time. We essentially upgraded and expanded out into other spaces, one for reaction monitoring, a high throughput system, and a method development tool. I'm going to touch on the newest parts. One is the HT, the other is the new LC. The HT I won't say too much about. As you probably saw Rob some of you may have seen Rob's talk last night. But essentially we put in the high pressure pumps and the box mounted up with the sample tower here, integrated very tightly with the auto sampler, so you get a really compact unit, it's really fast, made specifically for putting into the mass spec. Some data, you see here you got a couple of things here, the types of application spaces. Important thing, Rob talked last night, he was getting 1,400 samples per day, shooting for about 2,500, so we're pretty excited about that. Coming soon, the last slide. Basically, we've upgraded the Express 100. You'll hear more about this. Got the sensitivity in a place where we're real happy. Very, very fast separations. And summary, and that's us.
And thank you.